this video, I'm going to talk about stoichiometry, but in this type of stoichiometry, we're dealing with solutions. So that involves our concentration calculation, moles per liter. And anytime we're mentioning concentration in this type of stoichiometry, we're talking about molar concentration, moles per liter. Okay, so let's take a look at some examples to see how we can perform this method. So in this first example, they're telling us, or they're asking us, what is the minimum volume of 0.25 moles per liter magnesium chloride needed to precipitate all silver ions in 60 milliliters of 0.30 moles per liter silver nitrate? Assume that silver chloride is completely insoluble in water. All right, so we're taking a look at this equation that we're given, and what you always want to do is balance the equation. That always should be your first step, because if you get that wrong, your mole ratio is going to be off, which means your answer is going to be a little bit off, okay? So when I balance this equation, in order for me to do that, I would put a 2 here and a 2 here. So let's just confirm that all of my elements are equal on either side of the arrow. So I've got 1 mg on the left side, 1 mg on the right side, 2 Ag on the left side, 2 Ag on the right side, 2 Cls on the left side, 2 Cls on the right side, 2 NO3s on the left, 2 NO3s on the right. So that is a completely balanced equation. Then what I always like to do is right underneath whatever compound of the equation I'm given information for, I'm going to write that right underneath it. So I'm given in the first part of the question the moles per liter of magnesium chloride. And moles per liter, we're talking about concentration. So I know the concentration of magnesium chloride is 0.25 moles per liter. And then they're asking you, what is the minimum volume of that compound? So I'm asked to find the V. So V is equal to question mark is what I'm going to leave it as. And then I'm going to change my color because now I'm going to talk about what information I'm given for the silver nitrate. And I'm given 0.30 moles per liter. So concentration of AgNO3 is 0.30 moles per liter. And I'm given 60 milliliters of silver nitrate. So 60 milliliters. Always remember from our last week's stuff, it's always just easier for us to convert into liters first. So when I convert milliliters to liters, I have to divide by 1,000, which is going to get me 0.060 liters. Okay, so I'm going to write down here, V is equal to 0.060 liters. All right, so I'm given everything. I know what I have to find. Now it's just a matter of actually doing it and mapping out what I have to do. So first step I already told you is to always balance your equation. The second step is always going to be to find the moles. Now, I've got 2 compounds that we're looking at here, and only one of them can I actually find the moles for. So if I look here for magnesium chloride, I have the concentration, but I don't have the volume, which means I cannot find the moles for MgCl2. But for AgNO3, I've got both the concentration and the volume. So my next step, so my first step was balancing. Next step is to find moles. I'm going to put moles as N just to make it easier. Find moles of AgNO3. Then stoichiometry is always about mole ratios. So find the moles of what you're given, and then you need to use your mole ratio. So use mole ratio of the mole ratio to find the moles of what you need to end up with. So I can use the mole ratio to find moles of MgCl2, and then use that to then find the volume. So that's sort of my plan that I have. So first, use my concentration and volume to find the moles of AgNO3. Then use my mole ratio to find the moles of MgCl2. Then use the concentration that I'm given in the question as as the moles that we just found out to solve for the volume. So let's see what that looks like when we actually do our question. So I'm starting off with finding the moles of AgNO3, right? And I have the volume here. So remember in the previous slide, we said 0.060 liters. And then the concentration of silver nitrate. So I'm going to use these two values to find the moles of silver nitrate. So when I do that, I'm going to start off with 0.060 liters. And in order to find the moles, I have to have my units of liters cancel out. And remember, there's two ways that I can write moles per liter: moles over liter or liter over moles. So because I want my liters to cancel out, I'm going to write liters at the bottom and moles at the top. And in concentration, or whenever you have a term moles per liter, the number is always associated with moles. So 0.30 moles for every 1 liter. And not just any moles, right? We're talking about the moles of AgNO3. Now, a reminder again about what units we want to end up with. We want to end up with liters of MgCl2. That's what the question's asking us. How many liters, or what volume of MgCl2 did we have to start off this question? So I did my first step, which I'm going to use that color green. So I found the moles of AgNO3. Now, I'm not going to find the moles and then plug it in and then do a different step. I'm just going to do this all in one step, but I'm using different colors so maybe you can see the different parts of this question. Next, my second part is to use my mole ratio. My mole ratio, according to my balanced equation, is that there are 2 AgNO3 for every 1 MgCl2. So if I put moles of AgNO3 at the bottom, and I put moles of MgCl2 at the top, for every 2 moles of MgNO3, there is 1 mole of MgCl2. Now what I've done is that the moles of AgNO3 cancel out. We're not talking about AgNO3 anymore. Now we are able to find the volume of MgCl2. In order for me to find the volume of MgCl2, I need to get rid of the units of moles. I need to end up with the unit of liters. I'm going to go back to blue. So the concentration that I was given of MgCl2 was 0.25 moles per liter. I have to express, or I have to write, moles of MgCl2 at the bottom and liter at the top. So for every 1 liter, remember, in concentration, the number part of that concentration, so in this case 0.25, is always written with the mole. So 0.25 is written at the bottom. This cancels out my moles of MgCl2, which means that I can just type all of these into my calculator to get my final answer. And my final answer is 0.036. And to confirm, this has 2 significant digits. But I know that my question, this number, so 60, has 1 significant digit. So if I were to write this as my final answer, I'm going to get 0.04 liters of MgCl2. And that is how you do a question like that. Now for the next example, I'm going to show you the question here. Pause the video if you need to. Maybe try and do this, and then I will take it up so that you get to try and do this for yourself. Just as we did earlier, for a question like this, when you're given a reaction, first step is to always balance, right? So I'm given the reaction, luckily for me, so I'm going to balance this. So in order for me to balance, I'll have 2 Na on this side, 2 Na on the right side, Pb, 1 Pb, 1 Pb, 2 nitrates on the left side, 2 nitrates on the right side, Pb, I already did that, 2Cl and 2Cl. So this is a completely balanced reaction. Now let's read the question. If 325 milliliters, I'm going to stop right there. I'm going to convert that into liters, right? Always do that because especially in these concentration problems, you have moles per liter. So in order for our units to properly cancel out, you want to make sure that it has got to be in liters. So 0.325 liters of lead 2 nitrate solution reacted with an excess solution of sodium chloride. 6.34 grams of solid was filtered out of the solution. So in this question, we're given so I'm just going to write right underneath here, PbNO32. We're given the volume of PbNO32. Oops. And the volume of PbNO32 is 0.325 liters. And then they're telling you that there's 6.34 grams of the solid that was filtered out of solution. So that's part of my, the solutions. One of these compounds is the solid. How do I figure out which of these compounds is the solid? I have to now look at my solubility chart. And on the solubility chart, I'm able to find that PbCl2 is the solid. So the solid that was produced, I was able to get 6.34 grams. 6.34 grams is the mass of the PbCl2. So we've written out everything that we were given in the question. Now we have to think of a plan. Now I told you, after balancing, your second step is to try and find out the moles of whatever thing you can. So in this case, I have to find the moles. If I try to find the moles of PbNO32, I don't have enough information. I don't have the concentration which the question is asking me to find. So I wish I had concentration. If I had both concentration and volume, I would be able to find the moles, but I can't. Instead, let's take a look at the mass here. If I have mass of PbCl2, can I find the moles? I need another piece of information, which is my molar mass. I have my periodic table, so I know that I can find the moles of PbCl2. So using my molar mass, I'm going to find the moles, again, I'm going to write that as N, of PbCl2. And I'm going to use molar mass to do that. And if I am able to find the moles of PbCl2, what I can then do is use the mole ratio to find moles of PbNO32, and then use that to then find the concentration. With the moles of PbNO32 and the volume of PbNO32, I can solve for the concentration. All right, let's actually do this. Again, I'm going to use different colors for the different steps, but I'm going to do this all in sort of one row. So I'm going to use black for the first step. And my first step was to use the mass of PbCl2. My first step here, find the moles of PbCl2 using the mass and the molar mass. So I'm going to write out my mass here, 6.34 grams of PbCl2. And then I'm going to have to make sure that my grams cancel out. So PbCl2 cancels out. And then I have moles. Why do I need moles? If I take a look at this sort of mapped out step, I cannot use the mole ratio until I find the moles. The mole ratio is what makes stoichiometry a stoichiometry question, right? We use the mole ratio so that we can find missing pieces of information like the concentration of PbNO32. So for every 1 mole of PbCl2, I have 278.6 0.1 grams of PbCl2. How do I know that? If I look at the molar mass of PbCl2 from my periodic table, I know that it is 278.1 grams per mole. And that's what tells me that I can use this. So grams of PbCl2 cancel out with grams of PbCl2 so that I can now get to moles, which I can then use to find the moles of PbNO3 too. So according to my mole ratio, let me change my color first. I'll go blue. So let's take a look at my balanced equation. I had a 2 here and a 2 here. According to my balanced equation, for every 1 mole of PbCl2, not a laser pointer. Every 1 mole of PbCl2, I have 1 mole of PbNO3 too, right? So that is a 1-to-1 ratio, which is great. So now my moles of PbCl2 can cancel out. And then now I'm at my last step. I've got moles of PbCl2. I need to then take it a step further so that I can solve for the moles per liter of PbNO3 too. I've got moles of PbNO3 too. What I need now is liters at the bottom. And I was told in the question that I had 0.325 liters of lead to nitrate. So 0.325 liters of PbNO3 2, and then just 1 at the top. So why did I put the liters at the bottom? Because I want to end up with moles per liter. And when I type all of this in, or if I use my calculator to solve for all of this, I'm going to do 6.34 divided by 278.1 divided by 0.325. I will get the answer 0.0701 moles per liter. I've got 3 significant digits in my question, and I do have 3 significant digits in my answer, which means that this is the answer that I'm looking for. Okay, so that was part A. So this is part A of this question. Let's look at part B. So in part B, I am asked to find the molar concentration of the nitrate ions that were reacted. So let's take a look at the reaction side. The reaction side, I had nitrate coming from the PbNO3 I just found out in the previous part of this question the concentration of PbNO3 I can use that concentration to find the concentration of the nitrate ions. So the answer that I found previously was 0.0701 moles of PbNO3 for every 1 liter. And I want my answer to be moles per liter of NO3 minus 1 ions. Now, how do I get there? I can look at how many nitrate ions there is in 1 mole of Pb. So in 1 mole of PbNO3 In 1 mole of PbNO3 let's see how many nitrate ions there are. So in 1 PbNO3 there are 2 nitrate ions, 2 moles of NO3 minus 1. So if I plug this into the calculator, 0.0701 moles of PbNO3 times 2 will give me 0.140 moles per liter of nitrate ions. That kind of makes sense because if I take a look at the concentration of PbNO3, there will be twice as much nitrate ions, right, in terms of the moles for that same amount of liters. The concentration of the nitrate ions is going to be higher. That's pretty much it on stoichiometry of solutions. And there is more practice problems in the D2L underneath this. So if you want to try those, please do.